Next topic is divergence. So before going to discuss divergence, we have to know what is meant by flux. Okay, so flux is nothing but flow of energy through a surface. Okay, flux is flow of energy through a surface. So that energy is maybe due to electric field or due to magnetic field. Okay, so flux is how we define flux means it is also called flux is called as lines. So flux is called a line. It is nothing but line in a plane that contains or intersects electric charge poles or magnetic poles. Okay, flux is nothing but lines. So the flow of lines, just as simply keep in mind, flux is the flow of lines. So I told you flux is due to electric field and magnetic field. It may be due to electric field and magnetic field. So just we define the electric flux. So electric flux is nothing but this is the lines. So the due to electric field or due to electric field, this is electric fluxes. So electric flux is going along the green lines are electric lines. So flux is also called electric lines. So flux is called as lines. Next, I told you magnetic flux, right? So the magnetic flux is due to available around the magnet. So these lines are called magnetic flux. So this is called magnetic lines, nothing but magnetic line. Okay, now you know what is flux. So flux is maybe due to electric lines or magnetic lines. Now coming into the topic divergence. I told you next topic is divergence, right? So divergence is an operator which performed on vector. Okay, so previous topic we performed a gradient. Gradient should be done or should be performed on scalar value. So once you done a gradient of a scalar, your final answer is a vector, right? So the divergence is opposite to a gradient. So it should be performed on vector. Your final answer is a scalar quantity. This is the difference between divergence and gradient. And the definition of divergence is, so the divergence gives how much flux is entering or leaving a volume. Okay, if you have taken any volume, how much, that is how many number of lines entering or leaving in a volume per, in a small volume per unit volume. Okay, so simply it is defined as net flux per unit volume. So divergence is also defined as net flux per unit volume. Okay, this is one of the MCQ. Divergence is defined as net flux per unit volume formula. Clear? So the divergence are of three types. There are three types of divergence. One is zero divergence, positive divergence, negative divergence. Okay, zero divergence means not net flux inside a volume or a region. I consider this is your volume or a region. So here no flux. So number of incoming number of lines coming into the region and number of lines leaving the region are equal. Therefore, no net flux is available. See here, 6 lines are entering and 6 lines are leaving. Therefore, no net flux, zero net flux is available. That's why zero divergence. Clear, students? So what is meaning? What is mean by divergence? The definition of divergence is net flux per unit volume. Flux is also called as lines, right? Number of lines entering or number of lines leaving a volume per unit volume. Clear? So here equal number of lines are entering and equal number of lines are leaving. Therefore, this divergence is called zero divergence. Next is positive divergence. Positive divergence means, see here, if a vector diverges or spread out from a given volume. Spread out means from this given region, see center region, this is your this is your given region. From this region, the flux lines, the vector lines are spreading out. That's why it is called a positive divergence. Here divergence is available, so that's why it is coming out from the given region. That is called a positive divergence. Negative divergence means it converges, it covers, it attracts. This region is converging the flux or lines into that given point. Okay, that's why it is called negative divergence. It does not have any divergence inside it, so it converges, it attracts the flux lines are available in the available outside the point, given point. That's why it is called negative divergence. So three types of divergence: zero divergence, so equal number of lines coming and going outside. Positive divergence means it spread out the flux lines outside. Negative divergence means it attracts or converges the flux lines into it. Okay, these are the three different types of divergence. Now coming to our definition.